tendency give the representative value of the given data. There are three such measures, namely mean, median, and mode. The median is the middle value of the data. So, median is that value of the set of observations that divides the data set into two equal parts. Median is mostly used in situations where the data has some extreme values that distort the mean from what might be considered the typical value. For example, while calculating average productivity of workers, average salary of employees, and average house rents in a city, etc., extreme values might be involved. So for such data, where typical value is more important than the individual observations, we take the median as a better measure of central tendency. If the data is arranged in the increasing or decreasing order of their magnitudes, a value that divides these ordered observations into two equal parts is called the median of the data. So, in order to identify the median for raw data, we first arrange it in the descending or ascending order. Then, depending on the number of observations to be even or odd, the median is calculated as the mean of n by 2th and n by 2 plus 1th observation, or n plus 1 by 2th observation. Now, consider this frequency distribution of the monthly wages of 100 workers in a factory. We have to find the median wage for this data. For finding the median, we must arrange the given data in the increasing or decreasing order. Let's arrange it in ascending order. Note that you can also arrange it in descending order. For this data set, the total number of observations n is 100, which is an even number. So, the median is the mean of the 50th and the 51st observations. Now, how do you find the 50th and 51st observations? To do this, we rewrite the data as cumulative frequency distribution. Let's revisit the cumulative frequency distribution and learn how to compute the median of grouped data. What do you understand by the word cumulative? Cumulative means some sort of total, right? In this data, we can see that the number of workers who earn a daily wage of up to 1,200 rupees are 15. Also, the total number of workers who earn monthly wage of up to 1,300 rupees are 31, and the wage of up to 1,400 are 50. And workers earning up to 1,500 are 76, and the ones earning up to 1,600 are 100. The last column is in fact the cumulative frequency of the given data. Notice that the last cumulative frequency is equal to the total number of values. Why is that so? Well, the last cumulative frequency is equal to the total number of values because all of the 100 workers earn a daily wage of up to 1,600 rupees. So from this table we get the 50th and 51st observations as 1,400 and 1,500. And hence the median will be the mean of the two observations, which is equal to 1,450. Thus we can say that out of the total workers, 50% get wages below 1,450 rupees and another 50% get wages above 1,450 rupees. We have seen that in order to obtain the median for the data given as the frequency distribution, we need to convert the data to cumulative frequency distribution. The same method holds true for grouped continuous frequency distribution as well. Recall that raw data can be arranged in the ascending or descending order to obtain median. Similarly, the cumulative frequency distribution for group data can be of two types, namely less than type or more than type. Let's understand each type with an example. Given here is the data of the pocket money earned by 20 friends staying in a locality. Let's make the cumulative frequency distribution of less than type for this data. Here, one child earns between 0 and 100. So the number of children who earn less than 100 rupees is 1. Next, 5 children got pocket money between 100 and 200. So the total number of children earning less than 200 rupees is 1 plus 5, that is 6. The total number of children earning between 200 and 300 are 4. So children getting less than 300 rupees are 6 plus 4 equal to 10. Proceeding similarly, we get the cumulative frequency distribution. Notice that the last cumulative frequency is equal to the total number of values. This is because all of the 20 children earn less than 600 rupees. Let's now represent this data as the more than type cumulative frequency distribution. This time, we identify the total number of children who earn a pocket money of more than the given amount. We start with the total number of children who get pocket money more than 0 rupees. All the 20 children fall in this category. Next, we find the total number of children who earn more than 100 rupees. 19 children earn more than 100 rupees. Continuing in a similar manner, we find the other cumulative frequencies. So, we can convert the grouped frequency distribution into two types of cumulative frequency distributions, less than type or the more than type. In the first case, the frequencies are in ascending order, while in second case, it is in descending order. Now, can we convert a more than type or less than type cumulative frequency distribution back to continuous classes? For example, consider this less than type distribution. We can convert it to continuous classes by finding the frequency of each class from the cumulative frequency. Each group of less than 10 means that in the age group 0 to 10, there are 6 people. Also, the age group of less than 20 means that in the age group of 10 to 20, there are 13 minus 6, that is, 7 people. Proceeding in a similar manner, we have the continuous frequency table. Now, let's consider the more than type cumulative frequency distribution. This frequency distribution can be converted to continuous data as shown. We have seen how to find the median of raw and ungrouped data. Let's now see how to find the median of grouped data. We have the frequency distribution of runs scored by the batsman in a match. For computing the median of the grouped data, the first step is to calculate the cumulative frequencies. In grouped data, we may not be able to find the median or the middle observation just by looking at the frequencies. This is because the middle observation is a value in a class interval. So, we first need to identify the class in which the middle observation lies. The class in which the middle observation lies is called median class. To locate the class containing the median, we need to find the cumulative frequency of the last class n, and then find n divided by 2. In this case, n divided by 2 is 11. Now, we need to find the class whose cumulative frequency is greater than or close to 11. The median class in this case is 25 to 50. Now, we know the class in which the median lies, but we do not know the exact median. To find the median, we use the formula shown here. In this formula, L represents the lower limit of the median class. N represents the number of observations. CF representing the cumulative frequency of the class preceding the median class. F represents the frequency of the median class. And H is the size of the class interval. We assume that all class sizes are equal in size. We substitute the values in the formula to find the median to be 37.5. So, about half the batsmen made runs less than 37.5, and the other half made runs more than 37.5. Let's take another data set and find its median. We find the cumulative frequencies and then identify the median class, that is, the class whose cumulative frequency is greater than and close to n divided by 2, which is equal to 27.5. The class whose cumulative frequency is greater than and close to 27.5 is 1200 to 1600. Next, we use the formula to find the median to be 1350. So, about half of the apartments are of size less than 1350 square feet, and about half of apartments are of size more than 1350 square feet. So we have seen how to compute the median in case of group data. Note that median can be computed only in the case of continuous frequency distribution. But if the data is not continuous, we have to make it continuous first. Now, what if the data is given to us in the form of less than or more than type cumulative frequency distribution? Then, can we compute the median in such a case? Yes, we can compute the median, but first we need to convert the data to continuous class distribution and then use the usual procedure to compute the median. Let's solve another problem. Here the median is given to us, and we have to find the missing frequencies. The median of the given data is 25. We need to find the values of x and y if the total frequency is 50. We start by finding the cumulative frequencies. The total frequency, or n, is equal to 50. This means that x plus y is equal to 28. Let's call it equation 1. The median of the given data is 25, which lies in the class 20 to 30. Using the median class is 20 to 30, we get the values of L, CF, and F. We also have the values of N and H. So, substituting all the values in the formula and simplifying, we get the values of X and Y.